So the very first question is, as you know, we need GATE exam to join PG programs, right? For VLSA or communication and signal processing, any kind of specialization. So GATE exam is usually conducted in the month of May or month of February, and in the March the result is out. So academic session usually start in the August, mid of August. So most commonly students keep on asking, sir, we have decided that we want to go ahead with the VLSA domain. So how we can utilize those 3 to 4 months to shape up our skills so that whenever we join some campus, we can easily keep the pace with the requirement of the curriculum so that we can hone our prerequisite required. So you are the best people to comment on this. You are the best people because being a researcher, being a professor, you have some requirement that the student must have at least these courses and these prerequisites. So this question I'm asking generally for all kind of specialization, be it semiconductor technology, be it circuit designing, be it system on chip design, be it signal processing and communication. So I want to take your review on this.
So going to answer one by one. Yeah, so we have recently started MTech by research, right? Which does not require GATE also, right? Without that also they can enter. Of course, MTech regular one, which is through HTRA scholarship, this requires GATE, right? We generally allow GATE in electrical engineering, GATE in EC and GATE in instrumentation. So all the discipline people can join our course without having any difficulty. However, if they know device physics a bit, undergraduate level analog circuit designing and digital, that will be helpful and a bit part of embedded. That might be useful. However, we have started all the courses from scratch. It does not require so many things to study well before, but if they come before joining the institute, if they have already studied, then it will be actually beneficial.
Right. So what are those programming languages and software they should be accustomed with so that they can easily cope up with the course?
So right now there is no programming is required, right? But maybe Dr. Rahul can maybe comment more on that.
Yeah, thank you, Nitesh. So for the students, the couple of months which they can utilize is for, I think first they should clear their basics, what they have prepared for. So because here most of the courses are from the fundamental levels, but we at least expect the students to have the fundamentals cleared, whatever they have done before. So that has to be cleared on those few months. They can clarify or they can re-look at into their, because the way students are preparing for GATE is maybe a little different. Then we expect students to have a more conceptual view onto those things, those particular chapters or particular subjects from our VLSA aspects. So, but if they are into kind of, if they want to go into a digital part, so probably they need to have a little bit of a more programming kind of a mindset as well. Like, because in digital designs, we need to write a lot of HDL codes. These are called hardware description language codes when they enter into the VLSI in IIT Mandi or any IITs. Okay, so at least have a good logical understanding of what is programming. At least, let us say, at least the C programming should be known. And if they are well equipped to kind of understand Verilog codes, because if they are into C codes, they are writing C codes, because C languages are taught in the schools as well nowadays. They can easily cope up with the Verilog codes. So at least that part should be revised, and that would be very, very helpful for the students to cope up with what professors are teaching in the class and how the labs are going on. Okay, so more than teaching, the students are a little more scared about the practicals of the labs which are going on. So this kind of a homework would definitely help them to easily cope up with the cultures that we have in IIT Mandi or in any IITs they go. So that's all from my side.
Yeah, I have
one thing I forgot to mention exactly. So we need a Signalson system to be known properly. Then circuit theory. These two are actually bread and butter. Then like they can start their course very easily. Right? We are not starting from this side. Okay. But for analog and other things, we are starting from scratch because it's going from MOS side. But these two are very important, along with basic understanding of digital and basic programming. At least once they have done some programming.
So second question is that, again continuing the same thing, right? If you talk about the semiconductor technology and solid state device, this kind of specialization and fabrication kind of specialization. So electronics graduate might be well accustomed. They have studied physics in well. They have studied electronics devices subject in well. But when we see the eligibility criteria, mechanical people are eligible into semiconductor technology, instrumentation are eligible into VLSI, electrical are eligible into VLSI. So they have that doubt in mind that the final selection there is some seat distribution, seat matrix thought we are going to take more number of students from the electronics background. Or it's a general. It depends upon the capability.
Yeah, so actually, this hurdle should not be there. Anybody can be, because it's interdisciplinary. VLSI is a technology. So
Right.
technology is going to mature when you have to engineering, science, then it is going to convert into the technology.
Right, right.
So it is not any constraint. We are limited with that only digital circuit design or signal processing kind of things. So we required in technology, we require the people from the chemistry, we require the people from the physics, we require the instrumentation, we require the people from the mechanical engineer. So considering that, we are open for that. If you see, even if you see previously we have a wide spectrum.
Right.
We are considering the students from the electronics, MSc from electronics, and somebody did the physics, the specialist in the semiconductor or electronics. That is also what we are going to rethink that. We have just stopped this exercise from last couple of years because there is some constraints was there.
Right.
Okay, so but we are agree with that, and we are going to rethink that. We are going to open for that, and there is in being as IT, we don't have that much reservation for any kind of the acceptance. If the students is good, we are ready to that because some mechanical people can be do the good work in the electronics, on the design also. Okay, it depend upon his, then he going to be start those things. So the basic things are there. So we are not that much in that very strict about, or we have a reservation about the, we are not going to be go interdisciplinary. We are there in some specialization, it may be some issue there, but if the student so committed, it's not from our end, it is other end.
Right, right.
If the student committed, he want to do the signal processing in the interview, is perform good, he is going to be hired without any hesitation.
Right, right.
Even we are not hard and fast rule. Okay, if we have mentioned on the EC background or he should be into instrumentation, if he is so passionate about their career, okay, I want to build the career on the suppose signal processing.
Right.
So we are going to give the signal processing without any hesitation.
Okay. So second thing is that what I've seen, I keep on interacting with the professors of different IIT. It's very difficult to motivate students to pursue their research into interdisciplinary domain. They have a kind of fear. Even into PG courses also. I guess, sir, you belong to biomedical, right? So sometimes I'm finding it very difficult to motivate students that in biomedical also you are going to get great career opportunity and some interesting work to do. They basically take biomedical as a name because at bachelor level they don't have that much exposure what is biomedical going to happen, how being a engineering graduate in electronics and communication in electrical engineering they are going to effectively contribute into biomedical. So whether the course structure will be totally different, it will be totally new for them, it will be difficult for them to cope up with. So these kind of doubt basically they have. What is your view on this?
Uh, so one of the possible reason why most of the students have a scare towards particularly biomedical engineering is the biophobia that they have been injected with during their school days.
Okay.
Particularly in one of the saddest part of Indian education system is that biology is taught in a very poor way in most of the Indian schools, and naturally when the students come to the engineering colleges after the plus 2, they come with a scare for biology. So it is typically taught in a very by-heartive manner in most of the schools. Ours is of course an exception to it, but in general in most of the schools in India, it's taught in a very by-heartive manner. So one of the way by which this scare can be removed is when the students come post higher secondary, post plus 2, they can be exposed to the biology education from scratch. I mean, you do not assume that they come with some biology knowledge from the school. So unlike physics, chemistry and mathematics, which they have to acquire some knowledge to a certain
above some certain threshold to see themselves through the JEE, it is not needed that they should have some knowledge about some threshold in the area of biology for clearing the JEE. And given that the biology education is in general very bad in India, so it is very important that you start teaching them biology for biomedical engineering starting from scratch itself. So over here we have a BTech MTech dual degree program in bioengineering, where when we designed the program, in fact I was there in the committee, I chaired that committee, and when we started designing that program, one of the assumptions which we started with is that the students will be assumed to come with no knowledge of biology when they join this program, and accordingly we designed that program. Now coming to the EE department, when they come to the EE department, and given that we have a vibrant group of people working in different areas, starting from biomedical devices to biomedical circuits and systems to protocols used for communicating medical data, it is very important that students can be given basic exposure to circuits and systems and connected to the domain areas, giving some certain amount of domain knowledge in biology, with the help of which they can couple the domain knowledge as well as the basics they acquire from the conventional classes in circuit systems as well as embedded systems, or maybe some biomedical circuits and systems course, or IoT for medical applications, this kind of courses, and apply them in the domain areas. And if you see in abroad also, for example, I have seen in US universities or European universities, they don't really expect students to come to the universities with a vibrant knowledge of biology. But given that they are into the system, they interact with professors both in the engineering as well as the medical side, and that's how they get groomed and trained up over time. That's what happens in Johns Hopkins University, which is considered to be the best university for biomedical in the whole world. Or even if you go to other places like University of California at San Diego, or University of Texas at Dallas, these kind of places, you will find this is how they groom up their students in the area of biomedical engineering.
So you want to add something?
Yeah. So I as I said, I was from a pure circuits background, and then I moved into an interdisciplinary field. And so my professor back at Stanford used to say that if you want to do work in biomedical area, you go and sit with people who are in that field. Even if you have to wash their test tubes, you'll at least pick up something that they are struggling with, and then you can build solutions for it. So students need to be told when they are coming from a very fixed mindset that in India students generally focus on maths and physics, and that's their fixed mindset. They are not exposed to many other areas. They have to be pushed to challenge themselves, to learn something that is completely new, and to let them know that this time is an investment. And so I have to push my students when they are in the lab collecting biological data, and they generally have no clue about that data, that this is actually adding value to your work. They don't sense that in the beginning, and the job of the faculty members is to give them the sense that something new will come out if you come with your previous background, specialization in hard sciences, in technical sciences, and then you look at something that is completely different, something new will come out. So this inspiration has to be given to the students, that hurdle has to be crossed, and when two ideas come together, often something spectacular comes out of it.
So I want to know in brief, as per your experience, see, domain knowledge I have, if I'm coming from the electronics or electrical engineering.
Yeah.
But if I want to go into biomedical, obviously, as you're telling that we also need to have the hands on the biomedical, right? Or bioengineering also.
Yes.
So is it difficult to cope up with that, course?
It's not difficult at all in terms of coping up. As long as we are able to provide the right kind of courses, the students are often very successful in able to pick up the basic basic principles that are needed to be able to handle your work. And you don't have to go through the entire curriculum of biology.
Right.
You have to
as per your need.
You just have to understand what is needed for you. So I might know certain aspects of neurology better than most of the people working in, there's some of the technicians working in that. But as soon as I deviate a little bit away from what is needed for me, I know nothing, but that's perfectly fine. So you can select what you need to learn, and you can master all of that very quickly. So this fear that I have to learn whole biology is not true.
I would like to add a little bit to that.
Okay, just 1 minute. I want to add the MTech VLSI course, which has biology and other relevant electives are there. They have been designed such a way that the one who has BTech in electrical, instrumentation, or electronics and communication, they can understand all the courses very easily. There is no problem, right?
I would like to add to what Dr. Siddharth said. So, at IIT Mandi, we believe in giving a functional approach to training students in the area of biology, which actually wipes out from the mind that they have to buy hurt things, which has already created a phobia for them. So that actually enthuses students a lot to acquire knowledge in the domain area, and that is how, of course, the hurdle needs to be crossed. As he rightly said, that there is always a hurdle, that how to remove that biophobia from the minds of the students. So moment you start giving them a functional approach to learning, which has got a very important pedagogical value, that hurdle is crossed. And nowadays students, I absolutely am particular about it. Nowadays students really need a lot of motivation from learning compared to what it used to be some 10 years 15 years back.
Actually, today's world, students are more influenced with the technology, they are more influenced toward the AI and ML. So my last question is that, basically, in IIT Mandi, are we incorporating these AI and ML into VLSI technology or not? And in what direction?
So can I just interrupt here, because the discussion what was going on for the biomedical engineering or something. Okay, I just wanted to give you a different perspective what you have heard about this one. So you know that every challenge lies an opportunity to learn something new about from. Okay, and there is very limited scope in a particular area now to execute the plans and get into the even like the top level or something. So right now the science or the research or the engineering is totally interdisciplinary. So if you learn new area, new field, you have an opportunity. Okay, and last 3-4 years where the whole human race was struggling with a very small microbes. Okay, and there we learned that okay, there is importance of this particular area of biomedical engineering, where we need to have good devices first to detect, characterize, and then to eliminate it. Okay, so which means there is a lot of opportunity which is still there. And coming on to the point that whether the student have phobia about the biology or not, because you know that currently if you look at the school structures, the students, they are not sure at 10th grade whether they wanted to go into the engineering side or they wanted to go into the medical side. So what they do is they take both the courses. Okay, so which means they are not scared of taking the subjects. I mean, they are accepting the challenge. Okay, they wanted to buy some time to decide this particular area, whether they wanted to move into the engineering or they wanted to move into the medical science. Okay, but then they have certain amount of knowledge, so they are not scared about it. The only thing is that how to nurture them. Okay, and here at IIT Mandi, we have a lot of design practicum courses where the student from different stream, they work as a team. So which means the student learn from the other student. Okay, and this is one of the biggest opportunity, I would say, here, where they don't learn not only from the faculty members, they learn from their peers as well. Okay? And this is one of the biggest aspect, I would say, for them. So this way, actually, we are trying to nurture them in a right way. I think we should be able to build up some leaders in this particular area.
So my last question was that related to VLSI only. That in today's world we have a buzz around the artificial intelligence and machine learning technology. So how IIT Mandi Research Lab are incorporating them into innovation of VLSI technology?
Yeah, okay. So thanks for that question. So see, there are two aspects of that question. So one is AI and ML for VLSI, or is it VLSI for AI and ML?
Right.
So for example, for my former case, when you say AI and ML for VLSI, in that what we do is we use AI and ML to design the EDU tools and kind of make it more automated rather than by operated by the designers. We use those AI and ML algorithm to make our routing or so many or floor planning of the chip more efficient. So other part is we design a VLSI chip which basically does a training or the inference of the particular AI and ML. So that the second part is what we actually do in IIT Mandi, where we basically design AI and ML chips for various application. Like I'm working in one of the project with Subhojit, so where we have a joint PhD scholar who is working in designing a very energy efficient AI and ML chip for biomedical application, right? And for that we do have a very good course structure, which will definitely train you into how to do an architecture design, how to implement that. And we have a very strong group in AI and ML in our school. There's a lab on where a lot of signal processing and pattern recognition people are there. We're working on that, so we take a help from them as well. And we also motivate our students like to go and talk to those faculties, and especially to the scholars who are working on that field and acquire knowledge. And then we again cater them with the VLSI knowledge, and we have an amalgamation of very good research coming out from that. So definitely yes, the question what you're asking, we definitely cater the need where we make a VLSI for AI and ML. And we also back in few months we also had a plan of starting a new MTech course for AI in VLSI. So that's still going on. So probably in a couple of months or at least in this year, we'll come up with a new course where we say that MTech in VLSI for AI.
Great.
I would also like to just quickly. So I'll just quickly add that the era of where AI ML as standalone disciplines was the dominant thing is, in my opinion, coming to an end, because these things are the most automatable aspects. Very now, most of these tools are basically off-the-shelf tools, and with the advent of these large language models, even coding is being to a large extent being automated. So if students are not prepared for using AI ML in other applications and using AI ML as an assistance and not being the developers, just developers of AI and ML, they'll be finding difficulties in the future, in my opinion. So just focusing only on AI ML in course of time might be a poor strategy. So it's very important that whatever passion you have, whatever interest you have, you combine it with these data science.
Consider these as a technology tool.
Yes, very soon AI ML will be something like what your basic maths courses, your basic physics courses, it will be on par with that. So this is something that everybody will very soon learn.
True.
So it should not be seen as I want to do AI and ML. It should be seen as what do I want to use.
But right now the situation is, students want to go for high package, and they are preferring these kind of courses, right?
That era is gone. And we studied that time is so attractive.
Right.
Now all these shifted if you go for the abroad, you find these are taught in the polytechnical level. Okay, not a higher level. Okay, so these things are not that much now valuable, and we shifted, generation is shifted. So this programming started from the 6th class onwards, okay, which we started in the 12th onwards. So there's a huge gap now, and this should be implemented on the basically hardware. So that is a more in system level as compared to.
So I just want to add a little bit to what Dr. Satinder said, that the whole idea lies in how you adapt yourself to the waves of technology over time. So, I mean, of course, the basic things remain as it is. If I talk of electronics, the theory of drift and diffusion has not changed over the past 100 years. But in my short span of 2 decades of engineering education, followed by my research, followed by my teaching career, I have seen lots of devices starting from MOSFETs, then came these SOI MOS, then FinFETs and XYZ devices. But point is that the basic theory of drift and diffusion remain. So when we were middle school, at our middle school classes, we used to do logo programming, basic programming. Now, as Professor Satinder said, that students are doing C programming from class 6, 7. So the thing is that the idea of whether you do a limited loop or an unlimited loop, for loop versus while loop, whatever, those things are remaining. The only thing is that the syntax is changing over
Right,
time.
right, right.
So students have to be very much adaptable to the waves of the technology, and they have to accept wholeheartedly the change of technology over time. When I was an undergrad student, I read about 8085 microprocessor. Now it is not taught as a part of the IIT curriculum. So, but given that I know that how to deal with the architecture of the microprocessor and program the processor, looking at the architectural details, how to do the memory interfacing with the IO devices and so on. Whatever new processors and whatever new controllers have come, I have been able to adapt to it. So
Right.
that is the kind of adaptability that is needed. I mean, I can't say that whatever microcontroller I'm teaching now, I will be able to teach the same microcontroller in 2030 or 35. Maybe something new processor or controller will come, which I have to adapt to it.
Right.
So that kind of adaptability is very much needed over time.
You want to add something?
No, I just wanted to say that so the IITs should not only consider the contemporary need of the technology, we should be little more futuristic as well,
Right, right, right.
right? So the things which they learn over here should be little more useful when they go in the maybe in coming years as well.
Right, right.
So that's what I wanted to say.
So can we wind up now?